For 9.4, we're going to be talking about measures of variation, and a measure of variation describes how a set of data is distributed or spread out. So when we were doing all of our work with mean, median, mode, all that stuff, we kept talking about distribution of data, and remember that means how that data is spread out, if it's closely grouped together or clustered, if it's spread pretty far out, and there are going to be a couple of these measures of variation that we're going to be talking about. One measure of variation is range, and we've already defined range and written into our notes how to find it. So if you know exactly where that information is, then the only part about this you have to write down is up here. If you can't find your definition or how to find range, then make sure you jot this down too. But remember that range is found by subtracting the smallest value in a data set from the greatest value. So it really tells us how far apart our data is spread from biggest to smallest. So order it in, from least to greatest, and then subtract your smallest value from your biggest value to find range. Quartiles divide a data set into 4 equal parts. And when you hear quartiles or you see the word, you should be able to see this first part, which is quart, like quarter, and then you should be able to connect that then, like there are 4 quarters in a dollar. That's a part of the word that we can try to connect to. The median, which we've already talked about too, is actually the direct middle of a data set, so it's also technically the second quartile. We don't usually call it that because we only refer to it as the median, but in a minute you're going to hear about the first and third quartiles, so if you wonder what happened to the second one, it's actually the median of our data set. We're going to use this data set to learn a little bit more about these quartiles, so go ahead and copy this down. It's already in order least to greatest. Leave yourself maybe a couple of lines above and below it because we're going to do some writing as we talk about these quartiles. But we're going to start by finding what we know, which is the median. So when we notice here, we have an even number of data values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means that somewhere in my middle here, 1, 2, 3, 4, 5, 28, and 1, 2, 3, 4, 5, 30 are my 2 middle values, which we know we should then add those together, 28 plus 30, and then divide it by 2, which is 58 divided by 2, which if you do the math on that ends up becoming 29. Or you can realize too that 28 and 30 just have one number in between them anyway, which is 29. So this would be considered our median at 29. Once we find the median, you notice that we have 2 halves then of our data set. So we've got a lower half and the upper half here. And so to find the other quartiles, we look for the median of each of those halves. And remember, median is going to be the same even if it's not here. So if I look for the median of my lower half, I'm looking for my direct middle. And in this case, I've got 1, 2, 3, 4, 5 data values in my lower half, which would mean that this one would be my direct middle since there's an odd number. So this one would be what we would call the first quartile. And sometimes we just call that Q1, and that's again the median of the lower half of data. Then when we look at the upper half of data, we look for the median of the upper half, and again there are 5 data values, 1, 2, 3, 4, 5, so 32 is directly in the middle, and so this one is known as our third quartile, or sometimes we call it Q3. Now if we did have an even number of data values here or here, then we would do the same thing we did for median in the middle of the data set. We would add our 2 middle values together, divide it by 2, and then that would be our third quartile or our first quartile depending on where it was. And just in case you ever hear it called this, sometimes you will hear the first quartile or Q1 called the lower quartile, and sometimes you'll hear the third quartile or Q3 be called the upper quartile. And again, very rarely will you ever hear the median called second quartile, but that's technically what it is. And again, if you're also wondering why there's no fourth quartile, then you would realize here's sort of the first quarter of our data. This is our second quarter, this is our third quarter, and this is our fourth quarter. So there's no real name for that last piece. So the first quartile is really just the halfway point between the first and second quarter. The median is really the halfway point between the second and third quarter. And then the third quartile is really just the halfway point between the third and fourth quarter. So there's no name for that fourth one. The last thing we're going to talk about right now is something called interquartile range, or a lot of times you'll just see that abbreviated to IQR. And the interquartile range is actually the difference, which in this case, remember, that means subtraction. So it's the difference between Q3, or the third quartile, and the first quartile. And it represents the range of the middle half of your data set. It's just another measure of variation. In our example that we used before, this was our data set, and we figured out that the first quartile was 22, because if this was our middle, our direct middle, or our median, the lower half, this was the middle of the lower half, and then this was the middle of our upper half, so third quartile. So to find IQR, what we would do would be to just subtract Q3 minus Q1, and in this case that would be 32 minus 22, which would be equal to 10. So the interquartile range would be equal to 10 in this case, means the kind of middle half of our data is only 10 values apart. Tomorrow we'll take a look a little bit more specifically at some actual real-world problems that would use IQR so that you would understand a little bit better about what it would actually tell us in a data set.